review. Now, based on those benchmark assessments, not everybody remembers what a zero of a function is. What's a zero of a function? What is it? It's on the x-axis.
It's where the line on the x-axis.
Did you hear what he just said? Say it again.
Line x-axis.
Where's the line crosses or touches that x-axis? What's another name for that? The place where the one zero function. What's another name for the zero of a function? X-intercept. Yep. A zero of a function is the x-intercept. So, you know, blah 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 blah. We had this on our
Yeah, there's a lot of
they look like they really want you to know that. Do you get the message that you have to know what a zero of a function is? And is it that difficult? It's the what is it? It isn't the y-intercept. It's not that. It's the x-intercept. It's where you cross or touch. What do I mean by touch? If you have something like this, zip right back up. Crosses or touches. Those are zeros of a function. It's a value of x that makes a function f of x equal 0. Because what are the coordinates? It's going to be some x value, right? And what's the y value? 0. Y is always 0. Remember f of x, another name for y? It's where the function crosses or touches the x-axis, like Chun told us. It's an x-intercept. These are zeros of a function. A lot of us were forgetting it, and I did see like several questions on the benchmark with that. X-intercept. It's an x-intercept. It's an x-intercept, right? We just got to remember that. So when you have something like this, 0, 0, 0, 0, very easy to see when you're looking at a graph. Finding it algebraically is something else. Now we've got a lot of vocab here that can be confusing. Zero, solution, new word, roots, oh my. To find the zero of a function, set it equal to 0. Set the equation, set the function equal to 0 and solve it for x. Why? Because all x-intercepts, which is the same as a 0, have a y value of 0. So solving an equation means finding solutions, right? Y equals, 3x plus 1 equals 10. What's the solution? I am off it. Let me try this one. I'm going to start over. I got myself off the table. All right. 3x plus 1 equals 10. What's the solution? How many agree? Okay. So that's a solution, right? If you plug it back in, you get a true statement. That's a solution. Well, another word for solution is finding roots. And let's see it by doing this. If you have this equation, x squared equals 4, well, how do I undo squaring? Well, what does that mean? Dividing by itself. Dividing what by itself? I mean, in a way, what's the word I'm looking for? If you square something, what's the opposite? Square root. The word root. Right? So what would the solution or roots of x squared equals 4 do? Equals 2. And what else? And what else?
square root.
What else squared gives me 4?
2.
Negative 2. Right? What's negative 2 times negative 2? 4. So this one has 2 solutions. It has 2 roots. And so we get that word root from, you kind of have to take a square root to get there. Kind of. So we have other roots other than square roots, right? We have cube roots, fourth roots, right? We have different kinds of roots. But roots and solutions mean the same thing. And zeros and x-intercepts mean the same thing. So zeros of a function, you're looking at a picture, zeros of the function. Here they are. Same as the x-intercept, so they're kind of equivalent. Roots and solutions are what you get when you solve the equation. Y equals 0. Very subtle difference. A lot of people don't know there's a difference. For all intents and purposes, if it says find the zeros, find the x-intercept, find the root, find the solutions that make it true, you're kind of doing the same thing. You're setting a function equal to 0 and you're finding the values. Alright? So I just got to they don't mean exactly the same thing, but if you think of them as being the same, you're probably okay. Yes? Well, yeah, I guess you're right. I guess they are. Because this would be x squared minus 4 equals 0, and I want degrees. It's basically, solving this equation to find zeros. Okay. So, let's review how we've done this so far. Now, you're experts on first-degree polynomials. Do you know that? First-degree polynomial. What does that mean to be a first-degree polynomial? What? There's only one variable. Linear equations, right? Linear. What's the degree of a linear equation? 1. So you're good with this. They have 1, 0. Here's an example. Here's the 0. Here's its x-intercept. There's a case where you have no zeros. Okay? No zeros if you're like here. So I should say have at least 1 0. Can I have more than 1 0? Yes. No, I shouldn't say that. At most. I'm not with you today. It has at most 1 0. At most 1 0. It could have none. If we start looking at second-degree polynomials, and we will be spending a bit of time with this next week or so, they're called quadratic. Second degree. Quadratic. So you're going to have some kind of square involved. Second degree. So here's an example of a second-degree polynomial, x squared minus 3x minus 10. And I can make it a function by saying it's y equals that value. How many zeros does it have? I asked everybody to get a calculator. So we're going to do this together here. Turn on your calculator. Turn it out. We're going to go to lunch in a moment. We're just going to do this part first. So y equals this, x squared minus 3x minus 10. If you can't remember where x is, press y equals. You get here. And the x button is next to the alpha button. So x, square it, minus 3x minus 10. And then we're going to zoom to standard view. Zoom number 6. Maybe you're not keeping up. It's okay. We're going to do it on one of these. But I just want to show it to you. Shows a little thing like this. I can smile. How many zeros? 2 zeros. Right? It can have as many as. Can it have less than 2 zeros? Yes. You could have one of these that just touches and bounces back up. That's 1 0. You could have one that doesn't touch at all. So you can't have more than 2, but you can have 2, 1, or 0. And what's your clue here? You look at the degree. Can't have more than what the degree is. Yes. It what? If it's negative, it flips it over. Yeah. All right. When we come back from lunch, we'll talk more. Now, so just where we were, if you have a second-degree polynomial as many as 2 zeros, you might only have 1. You might not have any. Can you guess what might happen with a third-degree polynomial? Well, as many as how many? 3, or 2, or 1, or none. So the degree of the polynomial starts becoming important. It helps us figure out the maximum number of zeros this might have. So we might have as many as 2 when we're working with these quadratics. And we're going to be working a lot more with quadratics in the future. So the polynomial function is set to 0. We solve it by finding its roots, which gives us the zeros of the function. So if I want to find the zeros of a function, we've done this. If f of x equals x plus 3, how do I algebraically, right, using algebra, how do I find the zeros of this function? Set y equals to 0. In this case, I'm calling y f of x. So set that equal to 0. And then I solve this, right? So that tells us, whatever this graph looks like, at this point, negative 3, there will be something going through it. And then this line does look something like that. So now the question is, what if I'm working with a higher degree polynomial? I'm going to hide this for a moment. Let's see, what have I over here? X squared minus 3x minus 10. So if I want to find the zeros algebraically of this function, how would I do it? What's the first step? What's the first step? Turn y into 0. So you take the whole function and you set it equal to 0. Just like we did, same exact thing that we did with linear, but now we're working with quadratic, second degree. All right, let's solve this. Well, how do I solve this? Let's add 10 to both sides. problem. This is the problem. How do you get x by itself? This is the problem. Yeah, this is a square, this is a 1, you know, degree of 1. This becomes a problem. So to solve this problem, we're going to look at another way to deal with how do you solve equations like this. And we're going to be using something called factoring. And we're going to get into a little bit more what that means. This is the y of what we're doing right now. So let's see, what's the next thing? So finding 0 graphically, though, we can do that. So I've got a new little function here. It's called y equals x plus 1 times x minus 2. These two quantities. And I want to put them in my calculator. So you can do this with me. Turn your calculator on. Go to y equal. Right, press that button. Clear, press the clear button, whatever was in there. Now you're going to type this in exactly as t with the parentheses. So parentheses, x plus 1 times x minus 2. Yeah, right, there's nothing here. So just, Alex, exactly what you see here, this is what you're typing in. Well, it is times, isn't it? Isn't it times? Right, if there's nothing here, it's times. You can put a times here, it's okay. Yeah, if you put an x here, you put a times, you're fine, it's the same thing. Now I'm gonna graph it. It has two zeros at negative 1 and 2. We can just look at it, negative 1 and 2. Yes. So, well, yes, but there could also be for a degree of 2, 1, 0, or 2. Exactly. Now, what if this was in between the little spaces? And plus, I think it's a little hard to read. Remember, we did this once before, and I'm going to review it. See if you remember how to do this. Remember the calc button? Calc button. You see the trace? And see where it says calc right above it? Press second trace to get calc. What am I trying to find? The 0. So you want to press number 2. And remember, you get this little blinking cursor, I call it the spider. It says left bound. So you go a little bit to the left of the 0 you want to find. You press enter. Then it says right bound. You go a little bit to the right of the 0. Press enter. When it says yes, you just press enter. It's going to tell you that's 0. That 0 is negative 1. Yeah. How do you find the other one? I don't choose same thing. You probably looked at the other 0. So you repeat the process. Number 2, 0. And then now I'm bounding the other 0. It says go on the left side of it and press enter. Go a little to the right of it. Press enter. Press enter one more time. My other 0 is 2, 0. So let's see. I've got negative 1, 0. And 2. Well, it can't be 0, 0. Look. Do you have anything at 0, 0? No, here's my zeros. And that's only if you're having trouble reading them. Can you do that? Now, let's just look here. Okay, so we found the zeros. Do you notice anything? I don't know. If we were to do this algebraically, right, wouldn't I just let this thing equal to 0? Do we notice anything about what the zeros actually are and what we're looking at? The opposite number, right? If it's a 1, it's a negative 1. If it's a 2, a negative 2. Let's think about how you solve an equation. How do I know? How do I verify an equation if I find a solution to it? All right, so if I think the solution is negative 1, isn't this x negative 1? What happens when I plug negative 1 in? Well, what's negative 1 plus 1? 0 times, I don't even care what this is, maybe 3. Because 0 times anything is 0. How about if I plug a 2 in? 3 times 2 minus 2 is 0. So we actually found solutions to an equation. This is what we call factored form. Because factors are things we multiply. I'm multiplying two polynomials. It's in factored form. When I'm in factored form, all I have to do is set it equal to 0 and solve. So I'm kind of homing in on a way to deal with these. So finding zeros algebraically. Again, review. Set your function equal to 0. So if I set x plus 1 times x minus 2 equals 0, I use what's called the zero product property. Very simple property. If you are multiplying two numbers, and you get 0, what must be the case? What must be the case? I know, I saw you do that. I saw solve this equation, right? Subtract 1 from both sides, what do you get? And then, or maybe it was this factor that's 0. Let's solve that thing for 0. I know how to solve that. Add 2 to both sides, what do you get? 2. There are two solutions, x equals -1 and x equals 2. So I'm getting around this thing that I don't know how to solve it by using the zero product property. So this factoring idea, no, we did that already. The factoring idea is going to help us. Let's just practice finding zeros algebraically. These are in what we call factored form. I'm multiplying two things and I'm getting 0. So it must be that this thing was 0. This is near the bottom of page 1. Hopefully you're following along with me. Or this thing 0. Does everybody see where we are? Yeah? Right? Because A times B equals 0. This times this is 0. Either this is 0 or this is 0. Zero product property. If x minus 3 is 0, what's x? Add 3. If x plus 6 is 0, so how do I get two answers? This is one of these quadratics. It's one of these curvy bits. Now, we don't know exactly what it looks like, but I do know over here at 3 and -6, something's going on. So it's just showing you where the zeros are. What is going to be the solution to this equation? Well, either the m minus 7 is 0 or the m minus 9 is 0. So what's m? 7. Or what else could it be? 9. It could be either one of those. There are two solutions to the equation. And after a while, you kind of look at it, right? If you plug a 7 in, isn't that how you get 0? Plug a 9 in, isn't that how you get 0? So like Tori noticed, it's the opposite number. So if you have a -7 here, 7. If you have a -9, 9. If you have a positive number, the negative comes out. Now this one might be a little harder to see, but it's the same idea. This times this equals 0. So set your first factor equal to 0. Set your second factor equal to 0. Here's how we're going to find our two solutions. We know how to solve these. They're linear. So subtract 10. And then divide by 5. Your first possible solution is -2. Subtract 12. Divide by 4. And there's your second possible solution. Yes, sir? Yeah. That's right. Yes, we are.
So if you just divide those,
If I divide, what do you mean? If I divide, I guess I'm not sure the question. I'm dividing. Oh, because you're solving this. So what are you saying we should do? Divide by 5?
yeah, when you do 10 divided by 5, it's equal to this.
Oh, here. Solve your equation you're very, very good. I'm not 100% sure I understand what you're asking. If you divide through by 5 first, you can do that. You get n plus 2 equals 0 and n equals -2. So just solve this equation. Anyway, let's do it. Who followed? Because the important idea here is by putting things in factored form, I can solve more complex equations than I normally could just using those properties and equalities that we have in here. So factoring is important. Write this down. Because on the third day of factoring, when you're like, please no more factoring, factoring is important. It's how we solve complex equations. Factoring is important. Write it down. Awesome. So let's learn how to factor, shall we? Yes. Yeah, well, no, we were solving equations. We were solving equations. No, that's what we were doing. And you have to be able to factor to solve those equations. So again, what are factors? What are they?
Things to make up the product.
Yes, things that make up a product. So you rewrite a number of expressions as a product of primes. This is prime factorization. You've done this. Like factors of 6. 2 times 3, right? Isn't that how you get there? So I rewrote 6 as a product of prime numbers. You don't have to use 1 and 6. Now, what is a prime number? I guess I should make sure we understand what that is. What's a prime? What's a prime? The number that's only divisible by itself in 1. So give me an example of some primes. Give me a prime number. 2. 3. Is 1 a prime number?
No. No.
1 is not a prime number because you have to have 1 and itself. You need 2 numbers. With 1, you only got 1. But you have 5. What else? 13. How come not 9? 3 times 3 is composite, right? So it means I can't factor them. We can go a long time, right? Is there a biggest prime? I'll leave that for you to figure out. Now, there is a biggest prime. What do we mean by factoring a polynomial? We're going to break the polynomial down into products of prime polynomials. Polynomials that you can't factor anymore. That's what we're going to be doing. So if I give you a factored form, can I find the polynomial that goes with it? Like if I gave you a factored form here, can you find the number that goes with it? 6. How'd you get it? Multiplying. Same thing, if you want to find the polynomial that these are factors of, let's multiply. X squared times negative 2x times x times negative 2 combined with y. That's what I mean, right? Combine them. So this, if you were to factor, if I said here's a polynomial, factor it, you get that. So I'm going to be giving you stuff like this, and you're going to give me stuff like that. That's our goal of factoring. Starting with a polynomial and getting a product of prime polynomials. Oh boy. Okay. We can do that. We got time to finish up a little bit. There's 5 different factoring methods I'm going to be teaching you. We're going to work with number 1 first, type 1 factoring. And you see that? Yeah. If you're filling in the blank on the bottom of page 1, you want this. All right, you're multiplying them out. X squared minus x minus 2. All right, type 1 factoring. You find a greatest common factor amongst all the terms. You reverse distribute. So we know how to distribute, we're going to go backwards. And then you verify by multiplying. See this in red with exclamation points? That means don't skip. Don't skip. So here's an example. So we're on page 2. I want you to follow along with me. We're on the back now. I want to see if this can be factored. So I'm going to use my type 1 factoring which says find the greatest common factor. First, let's look at the numbers. You have a 6 and you have a 12. We've done this before. What's the greatest common factor? 6. Now the variables are actually easier. You have an x squared and you have an x. Greatest factor they have in common? X. So we're going to reverse distribute. So the thing that we're actually multiplying by is this greatest common factor. Now I've got to find the stuff inside. Can we do that? Well, you multiply to distribute, right? So you divide. How to do it backwards? What's 6x squared divided by 6x? X squared over x. 12x divided by 6x? 2. How do I verify? Let's distribute back. Do I get what I start with? Yep. Then I factored correctly. You just factored the very first polynomial. Let's try another one. 12x plus 42y. So you look at the 12 and you look at the 42 and you say, what's the greatest factor that they have that's the same? Greatest common factor. Like 12's not a factor that bad. Then you look at the variables, x and y, do they have a greatest common factor? No, nothing's the same. So 6 is what's outside my distribution. Divide by the 6, you get a 2x plus a 7y. Just divide it. And then how do you verify? We work backwards, right? We just multiply. So 12x plus 42y. Did I get what I started with? Looking pretty good. Let's try this guy. I've got a 4 and a 24. What's the greatest common factor there?
4x.
Well, now let's look at these guys. I've got variables. What's the same? And if you need to expand them out at first just to see, what's the same? There's 3 factors of x. So x, 2. Now we're going to reverse distribute. I know what goes outside there. Now you can divide. 4x, so the 4 that becomes a 1. X to the 4th over x cubed. X. 24x cubed over 4x cubed. Well, there's a 1 right there. 24 over 4. you want to get greatest, right? The biggest one. Yes.
Okay, so I just want to make sure that I'm doing this right. So if you do those numbers, you'll look at like which like what they have in common.
And divide that out.
Okay.
That's basically what you're doing. You look for what they have in common, divide it out. Now you want the greatest one in common. Always check what you got left in here just in case you didn't get the biggest one. If it's still factorable in here, factor again. I see a 2. And I see another x. So I get 4x cubed. Now divide by that 2x and we'll get back to what we have here. We'll try to get the biggest one first. Okay. Now we're going to solve equations. So to solve equations, you put all terms on one side of the equation, 0 on the other. Factor, that each factor equals to 0. So let's do an example here. We're getting towards the bottom-ish, middle-ish here. So all my terms on one side, 0 on the other. Greatest common factor. Let's see, 2 and 8. 2. What about an x squared and an x? X equals 0. Don't forget your equals 0. Now you're solving an equation. Divide by that 2x. 2x squared over 2x. Plus what? 4. And I do a quick check. That's 2x squared plus 8x. Looking good. Now what does the zero product property say? You got a product here, right? And it equals 0. So this bit was 0. Or if this bit gets 0. 2x equals 0, well, what do you get? X equals 0. And then what goes out over here? So I've solved an equation that's normally I wouldn't know what to do with it. Factor it, that each factor equals to 0. If you plug in a 0, you're going to get 0. If you plug in a negative 4, you're also going to get 0. 2 solution. Everybody follow that? Question. Where's your question? Yes, ma'am.
How did you get from 0 to
I said, all right, see this thing times this thing, right? Equals 0. So either this was 0 or that was 0. So I set them both equal to 0. And then I solve this equation. Subtract 4 from both sides. Let's try another one. Okay, now I don't have a 0 on one side. How do I get it to be on one side? Subtract it on over there. So that's what I mean by all variables on one side, 0 on the other. Then we factor. Do I have a greatest common factor? Well, let's look at 9 and 21. Is there a greatest common factor? No. Yes? 3. How about y squared and y? Y. Why not? So now I divide by that guy. What am I getting? 3y minus 7. And what about it? It equals 0. This thing times this thing equals 0. So it must be that this factor was 0. Or maybe it was this factor that was 0. If 3y equals 0, what's y? 0. It's like the mini, zero product property. Add 7 to both sides. And then divide by 3, you get a fraction. So what? A fraction, sometimes it is. Yes?
How come you don't get rid of the y when you divide the number that is used but you do it and then
I can get rid of the y. What's y squared divided by
no,
y?
I mean like,
Y.
yeah, and there like a 3y and it's 7.
Uh-huh.
How come you have the y in there?
Because I've divided y over y is a big old one. I'm just doing a division here because I want to know 3y times something got me to 21. So I want to figure out what it was. You multiply back. Doesn't it work? There's 9y squared minus 21y. Let's do another one. I'll see if I can hone in on your question here. I want everything on one side. Subtract that 36h. The greatest common factor. The 12 and the 36. 12, right? Now the h squared and the h. Okay, so stay with me for a minute. What am I going to divide by? Quinn. Right? Good. And that's what goes inside when I reverse distribute. So I'm distributing to get that, but I'm going backwards. So what's 12h squared divided by 12h? H. And what's 36h divided by 12h? Right? H over h? So that's where the h went. I divided it out. And now I've got something times something is 0. So it could be this guy was my 0, or or maybe it's this guy. That's 0. Solve them both. H equals 0 or H equals 3. Plug them back in and you'll see that you get it works. Holy cow, that's hard. Well, it's new. So everybody who said division was crazy hard and you can't possibly do it, remember how by the next class you're all doing it? Same thing will happen here. Do you need to practice it? Oh, you betcha. So we'll start with the U tries, working on that, and I'll hand out homework. But please work on this while I'm doing it. Yeah, I'm just going to display the answers. Oh, that's on the right page. Here we go. I'll display the answers on this one. So you can check. How else do you check? Plug in the negative 4. You're going to get 0. Plug in the 5. You're going to get 0. That's how you check. How do you check these? Multiply that. This one. And plug them back in and see if it works. What? Nope. No. That's a 1. No, that's a 1. That's negative. That's right. 2 minus 2 is 0. Negative 2 plus that is 0. And then you plug it in, right? Plug in the 1. Listen, good thing practice. Please remember. Should we wait till what's today? Monday? Let's wait till Wednesday and maybe have store third block or second block. Should we wait till then? No. Do